How's it going, everyone? In this video, we're going to discuss everything about solar eclipses. Why they happen, the different types of solar eclipses, how come they're so rare and unique, and some specific phenomena related to them, and how they affect conditions on Earth. We'll get all into that, so let's get to it. The diagram that you see here, this is the diagram for a total solar eclipse. So you have the moon placed between the Earth and the sun, and the sunlight, well, where it can come from is bounded by the edges of the sun. Okay, so these red lines that you see here is how that sunlight can interact with the moon. And this is not to scale. Of course, the sun is much larger than the moon and the Earth, but it's also much farther away. So we can see where the sunlight is partially blocked by the moon, and that's these areas here. Okay, so in this diagram, sunlight from the top of the sun will reach that part of the Earth. Okay, and sunlight from the bottom of the sun will reach this part of the Earth. But you have this area in between, okay, where none of the sunlight will reach, not from the top of the sun, not from the bottom of the sun, okay? And that is where you have what's called the umbra, okay? This is the full shadow of the moon, okay? And you see it's touching Earth at some particular point, okay? And this is the part of Earth that will experience a total solar eclipse. Now this gray area, this is called the penumbra. Okay, now this is a partial shadow where the light is dimmed, where part of the sun is blocked, but it's not completely blocked. Okay, so if you're standing at part of the Earth where you are under the penumbra, well, you will see the moon, and you will see that it's blocking part of the sun, but not all of it, okay? So it would be dimmer, but it would still be bright outside. Whereas if you're standing somewhere over here, then you would actually see the moon completely blocking the sun. But although it would become dark, you wouldn't be in complete darkness, okay? Because what you would see appear around the moon is something, it would actually be white. I'm making it orange here to make it visible, is something that's called the sun's corona, okay? Now this is the outer layer of the sun's atmosphere. These are hot gases that come to the exterior of the sun from inside, and it's called corona because that means crown. Okay, it kind of looks like a crown. Now normally you never see this, but during a total solar eclipse, when the moon is covering the sun completely, then that corona is visible. See, the corona is less dense than the rest of the sun, so it's much more dim. And just like the sun blocks out the stars in the sky because it's so much brighter than those stars, so you cannot see them when the sun's out, for the same reason the sun blocks out the corona, its own upper atmosphere. So we can't see it normally, but when the moon entirely covers the sun, if you're standing in that part of Earth right there, well, then you can actually see that corona. Okay, so what is that corona? Why is it there? So imagine you have a candle. It's burning and it seems to be pointing upward, okay? And the gas seems to be going upward from that candle. Why? Well, because it is hotter. It's less dense. And so it moves up. What is up? Well, up is opposite the direction of the force of gravity. Okay, and so because it's less dense, a pocket of it is lighter, so it floats higher up. Well, on the sun, opposite the direction of the force of gravity is away from the center of the sun. Okay, so these hot gases move away from the center of the sun in that direction, and they end up on the outside of the sun's atmosphere. So the sun's corona is very, very hot. It's less dense, so it's not as bright, and normally you can't see it. You can only see it if the moon is completely covering the sun. So that's pretty cool. You get to see something that otherwise you'd never be able to see. Okay? Now, sometimes pieces of the sun will actually fly off into space. Okay? From the atmosphere, the sun's atmosphere, they'll fly off into space. And sometimes those pieces, some of them may actually reach the Earth. And when they enter the Earth's atmosphere, that's a phenomena that we call the northern lights, or the aurora borealis. Okay? And if you're lucky enough to see the sun's corona, well, you might be really, really lucky and actually see some piece of something fly off. Some bright, shining part just fly off farther off and disappear. It's unlikely, okay? Unlikely to see that, but hey, it's possible, all right? Now, this is all during what's called a total solar eclipse, but not all solar eclipses are total. In fact, most of them are not. In fact, for most of them, the umbra, okay, this is that darkest part of the moon's shadow, for most solar eclipses, that doesn't even touch the Earth, okay, and the situation looks like this. If we were to draw these rays from the sun to show how the moon would block the sun's light, we end up with a situation like that. So the umbra, the darkest part of the moon's shadow, would be up here. The penumbra, which is where part of the sun's light is blocked, but not all of it, that would be up here. And if we were to draw Earth, let's say the Earth is right there, well, as you can see, the umbra, the darkest part of the moon's shadow, it never touches the Earth. Okay, it just misses the Earth. But the penumbra, the partial shadow, does touch the Earth. And if you're standing there, what you will see is that partial eclipse where part of the sun is blocked by the moon and part of it is not, right? So it's dimmer, light looks different, but it does not get dark. Okay, now during a total solar eclipse, if you're in this region here or this region here, then that also looks like a partial solar eclipse, but there is one particular subset of the Earth's surface where you do get that total coverage of the sun and a view of the solar corona. Okay, now it might be tempting to say, but okay, hold on. The moon is supposed to be between the Earth and the sun for a solar eclipse. So does this situation here, a partial solar eclipse, does that really count? Right? The moon doesn't really look to be exactly between the sun and the Earth. So isn't it going to get there and be between eventually? Well, here we're actually looking at the situation from the side. There's the axis of the Earth's rotation. Okay? And the moon is not rotating this way. Okay? The moon is rotating this way. Okay? And if we were to look at things from the top, so to speak, then we would have the sun here, the Earth here, there's our North Pole, and there is the Earth's rotation, and there's the moon. So it is in between if you look from the top, but if you look from the side, the moon is actually higher up, high enough that the umbra, the darkest part of the shadow, does not touch the Earth. Or alternatively, it might be too low if we flip this, right? Then again, the umbra is too low to touch the Earth, and so it's only a partial eclipse. Now, the third type of solar eclipse that you can have is where the moon is centered, but it ends up being farther away from Earth than usual. And you end up with a situation like this. So there's your umbra, there's your penumbra, and notice that there's one area that we actually didn't color in. Okay? And that's this area right here. Okay, and this is called the antumbra. All right? So it's opposite of the umbra, that darkest part of the shadow, right? But the light from both top and bottom of the sun can reach there. Okay? And if the Earth happens to fall far enough from the moon, okay, now compare that to the very top picture here, right? The Earth is close enough that, well, no antumbra can form, right? Like if the Earth was missing, you'd get an antumbra right here, but the Earth is not missing, so no antumbra forms. If the Earth is far enough, you do get an antumbra. And well, what would that look like? Well, if you're standing here, it just looks like a partial solar eclipse where the moon covers a part of the sun. But if you're standing right here, well, you see sunlight from one side of the moon and you see sunlight from the other side of the moon, but you can't see it from the middle. And remember, we are talking about spheres here, not disks. Okay, so you can also see sunlight from behind and you can also see sunlight from in front, and it looks like a ring. Okay, so if you're standing in this region, you will see the moon, and around that you get to see this thin disk of the sun. Okay, and that's called an annular eclipse. Okay, it comes from the word annulus, which means ring. Okay, sometimes it's referred to as a ring of fire eclipse. So it does not turn dark, although it does get dimmer, and the sun appears to be a ring rather than a circle up in the sky. All right, so that is an annular eclipse. Now, the reason we get to see sometimes annular eclipses, this ring of fire, and sometimes total eclipses, which is this complete blockage of the sun and we see the corona around it, is because sometimes the moon is just close enough to block out the entire sun, and sometimes the moon, although it's between the Earth and the sun, is just far enough that it can't block the full sun, and we see that ring around it because the distance between the Earth and the moon does fluctuate. All right, but that distance, yeah, it fluctuates, but it's approximately 400 times smaller than the distance from the Earth to the sun. And that sun also happens to be about 400 times larger in terms of radius. 400 times larger than the moon. Okay, so the sun is about 400 times farther. It's also 400 times larger in terms of its radius. And as a result, the sun and the moon appear to be roughly the same size in the sky. Okay, and because they're roughly the same size, then with the fluctuation of the distance between the Earth and the moon, we get this situation where sometimes the moon is a little bit bigger than the sun, in appearance and we get this situation here. And sometimes the moon is a little bit smaller than the sun in appearance and we get this situation here. Now, if we didn't have this coincidence where the sun is roughly 400 times longer than the moon and roughly 400 times farther than the moon, well then we wouldn't be able to have both total and annular eclipses. Right? If the moon was just appearing always big enough to cover the entire sun, we would only have total or partial eclipses. And if the moon never appeared big enough to be fully covering the sun, well then we would only ever have partial or annular eclipses. Okay, but because of that coincidence, it's approximately 400 times bigger, the sun approximately 400 times longer and approximately 400 times farther, the moon and sun do appear to be roughly the same size. And so that slight fluctuation in the moon's distance from Earth results in us being able to sometimes see annular eclipses and sometimes see total solar eclipses. Now, there is a fourth type of solar eclipse that can occur. And this is a combination of the annular solar eclipse, which you see here, and the total solar eclipse, which is on top. Okay, and that's because the Earth is curved, right? So there's your curved Earth, and sometimes, as the moon moves past the Earth, and it is ever so slowly moving, the moon's shadow might be such that the umbra does not reach the Earth's surface at one point as the moon is passing by, okay? But it will reach the Earth's surface as it's passing by the more bulgy part of the Earth. Okay? So, as a result, people observing in one place will see a total solar eclipse, and people observing in another place will see an annular solar eclipse. Okay, they will see that ring of fire. Now, the total solar eclipse and the annular solar eclipse, they are always accompanied with a partial solar eclipse at other parts of the Earth. Okay, so the partial solar eclipse being present in this situation too isn't particularly special, okay? But what is unique, and this is called a hybrid solar eclipse, which is the most rare kind, is that some parts of the Earth will see that ring of fire, while other parts of the Earth will see that solar corona. Okay, so here people would see that corona, and here people would see that ring of fire, that ring of the sun that is not completely blocked by the moon. Okay, because the moon is just far enough and the Earth's bulge is just perfect that for this particular solar eclipse, for some locations the moon is too far that they get an annular eclipse, and for some locations the moon is close enough that they get a total solar eclipse. Okay, now just to show this from a different perspective, okay, if here's your Earth, and you imagine the path of the moon's shadow as it crosses the sky, okay, if the path of the umbra misses the Earth, but the path of the penumbra does get part of the Earth, that is a partial solar eclipse. Whereas if the path of the umbra does pass the Earth, okay, well then that part of the Earth that it passes will get either a annular solar eclipse or a total solar eclipse or a hybrid, okay? And around that area, there would be a partial solar eclipse, okay? Now, depending on how far the moon is from the Earth during that particular eclipse, that would determine whether this second case is a total eclipse or a hybrid or an annular eclipse. And if you are on the path of the moon's umbra or antumbra, okay, while the moon is getting in position, you will also see a partial solar eclipse, right? Because first the moon would block part of the sun, and then it would move forward and eventually block all of it, causing either a total or annular eclipse. Okay, so why are they so rare? Well, they're actually not so rare. Solar eclipses happen approximately twice a year. Okay? And the other question people ask is, well, how come they don't happen every time we have a new moon, right? So if we imagine the sun-moon system, there's our moon rotating around the Earth. As the Earth rotates around the sun, okay, how come we don't get a solar eclipse every single time that we have a new moon? New moon being that the moon is passing between the Earth and the sun. So if you look to the sky at night, there's no moon there. Why? Because it's on the other side of the Earth. Okay, and that's called a new moon. All right. So how come we don't get a solar eclipse every single month during the new moon? Okay, because a lunar cycle is 1 month. That's why it's called a month. It's related to the word moon. Okay, well, remember the situation here where the most common solar eclipse is a partial solar eclipse because the moon's umbra misses the Earth and only the penumbra reaches the Earth, right? So you can only see a partial solar eclipse. Well, what's even more common is both the umbra and the penumbra miss the Earth. Okay, so if we go here, okay, we're looking at the situation from the top. If we now flip this and look from the side, there's our sun. Okay, there's our Earth. There's the axis of the Earth's rotation. And this is the plane of the Earth's rotation around the sun. Okay, so it's a disk. We're looking at it from the side. All right. Well, the plane of the moon's rotation around the Earth is actually slightly angled. Okay, so it's rotating like this while the Earth is rotating like that, all right? And what happens most new moons is that, well, I'll draw it for you. Both the umbra and the penumbra will miss the Earth completely. Okay? There's your umbra right there. There's your penumbra. Okay, there's your antumbra in white in the middle. We colored it red in the past. The moon's shadow misses the Earth completely. Most new moons. Okay? Now, what if this Earth, okay, as it's continuing its path around the sun, what if it moves from here to this part of the orbit. Okay? Now I drew it a little bit below. It would actually be right here in front of the sun. Okay, well what would that look like? Well, then we would have our sun. We would have the Earth in front of it, right? And the moon's orbit around the Earth would look like that. Okay? So the moon would end up actually blocking part of the sunlight when it's on the other side of the Earth. And when it's behind the Earth, well, then actually the Earth's shadow would fall onto the moon and you would get a lunar eclipse. And it takes about 4 weeks for the moon to make one cycle around the Earth. So 2 weeks between new moon and full moon. Okay? And because of this alignment, every time you have a solar eclipse, you will also have a lunar eclipse, either 2 weeks before the solar eclipse or 2 weeks after the solar eclipse. Okay. Now I do have a separate video on lunar eclipses and why they happen and how and all that, and I'll put a link to that in the description. Now this particular alignment happens about twice a year. As the Earth is rotating around the sun, it'll happen once on the side that I just drew and once on that other side of the sun behind it. Okay, like back there. All right, and that's why you get approximately 2 lunar eclipses and 2 solar eclipses per year. Okay. Now people might ask, well, hold on, we don't get 2 solar eclipses per year. Well, you don't get them, but the Earth does. Okay. Let's go back to this diagram here. All right. Whether it's a partial eclipse, which is the most common one, which is shown by the top path of the moon's shadow, or the more rare total eclipse or hybrid eclipse or annular eclipse, which is shown by this bottom path of the moon's shadow, most of the Earth doesn't get any light blocked. It's only a subset of the Earth that gets to see a solar eclipse when a solar eclipse happens. And that's why wherever it is you are living, for that particular location, solar eclipses are quite rare. But if you were to travel around the Earth chasing solar eclipses, you would be able to find one approximately twice a year. Although most of them will be partial, okay? And the annular or total ones are more rare. And of course, if they're happening mostly over the ocean, well, then even if you're chasing them, it would be much more difficult for you to get to see them. Now, another interesting phenomena when you're observing these eclipses is that as the moon passes in front of the sun, here I've been drawing it black, but the moon actually isn't completely black. It is somewhat illuminated. And the question is, well, why? If the source of light is behind the moon, the source of light being the sun, what exactly would illuminate the moon? Well, what exactly would illuminate the part of the moon facing the Earth, right? Let's go to this diagram here. All right. The sun's coming from the left of the screen, so this part of the moon here, well, it's not getting any sunlight. Why wouldn't it be completely black? Well, imagine you were standing on the moon, on that part of the moon. What would you see? Well, you would see the Earth. You would see the moon's shadow falling onto the Earth. But you would also see this part of the Earth, which doesn't have the moon's shadow on it. And this part of the Earth, it doesn't have the moon's shadow on it. Okay? And of course, right here, there would be partial light from the sun that you would see. And that sunlight, some of it, would actually be reflecting towards the moon. Okay, so the Earth is being illuminated by the sun. If we go back down here, right, all these parts of the Earth, let's say it's the bottom situation, right, total or annular eclipse, all these parts of the Earth are being illuminated by the sun. And if you're staring at the Earth from the moon, you would see those parts of the Earth fully illuminated. And some of that light is reflecting onto the moon and illuminating it. And that's why the moon is not completely dark. The part of the moon facing the Earth is not completely dark during a solar eclipse. And final question, does the solar eclipse affect human behavior? Well, yeah, people want to see it. A lot of people want to see it. Well, a lot of people want to rush to see it because it only lasts, well, if you count the partial component, a couple of hours. If you're only looking for the annular or total component of it, we're talking about a matter of minutes or maybe half an hour, right? So people are rushing. There can be more traffic. People are more stressed, and there can be more traffic accidents. Well, that's an effect on human behavior, right? So be careful if you're driving out there, all right? Another effect, well, it could have an effect on safety. It's not safe to look directly at the sun without protective eye gear, right? Sometimes schools close so that at recess, kids don't just stare up at the sun because there's no way teachers can control that. Schools closing can have an effect on behavior. And a long time ago, it had a terrifying effect. Before people understood that lunar or solar eclipses are just parts of a regular cycle that happens, people were terrified of it. The sun is pretty important. It keeps us warm, okay? It allows plants to grow. It gives us light. And people would see the sun being blocked, and that would scare them. Okay, they would think, oh no, what if it becomes blocked forever? Okay, now we understand that this is just part of an ordinary cycle. All right? And another effect it could have is that it actually affects radio communication. The amount of solar radiation hitting our atmosphere reduces during a solar eclipse. Now that has a cooling effect, okay? And it can also reduce the density of electrons in Earth's upper atmosphere. And that can result in poorer propagation of radio waves that are used for communication, for navigation. Okay, now this would just affect the region where that eclipse is happening, right? And it's temporary, but that is an interesting effect that actually does occur. And since a solar eclipse can only happen during a new moon, all the effects that occur during a new moon will also occur during a solar eclipse. Now, one of the effects that happens during a new moon is that, well, at night there's no moon in the sky, right? Because the moon is between the Earth and the sun, all right? So nights are darker, okay, because there's no moon illuminating the night sky. The other effect it has is tides are stronger, okay? Tides happen from the moon and its gravity pulling onto the Earth's ocean. So if there's the Earth, and there's going to be a really crude description of the Earth's oceans, okay? Much exaggerated, okay? The ocean is a big heavy thing that can change its shape, okay? It can move around because it's liquid. And when the moon is new, okay, the gravitational pull of the moon is aligned with the gravitational pull of the sun, right? So the force of gravity from the moon would be in this direction onto the Earth's oceans, and the force of gravity from the sun would also be in this direction, okay? So they're aligned, and so you actually end up with stronger tides during any new moon, including during a solar eclipse. So that is solar eclipses, why they happen, how they affect people, the types of solar eclipses, why they seem to be rare, and I hope you enjoyed that, and until next time.